the token that will have defined some literal, and that literal will be fixed. You cannot change during the program anymore. So the constant in Java will be written as a name, so an identifier should be given, and that can hold a value as well, and that value is literal. A sequence of letter or digit is basically called literal. So these values will be hold, and this one will be the final keyword will be used, final. The keyword will be used, final. Literal means that like these are the values, yes, the values, which are a sequence of letters or digits. Together, those are called literal. Okay, so I have some example here about literal. So integer literal, 10, 5, the value. Okay, floating point literal, the values. Okay, so Boolean literal, true and false. Character literal, A, B, C, D. String literal, the computation of the characters. So those are basically called values for the variables, right? So those are basically called literal, which is the sequence of digits or characters. Okay, digits or alphabets, digits or letters. Okay, so when you in Java, we call this one like without the final statement. This is a variable. We have initialized the value. But when you say final, that means the value is final. So this one behave, this token or this identifier or this variable will behave as constant. So we cannot say this one is a variable, because if it is a variable, the value can be changed. Variable value can be changeable. But here the pi is a fixed value. So this one is a final. So that's why once you define the value, it cannot change in the further of the program. In Java, we have written we write the constants by using capital letter, uppercase letter, pi, not like pi or pi. So pi, we have written in this formulations, okay, capital letters. Now the escape sequence. So public class control character. So this one is some escape sequence we have, that to print those sequence, to print those characters, we need backslash to provide, like backspace. If you want to do backspace, so in your program you are writing and then backspace. So if you want to do the backspace, then /b is the backspace, /n is the new line, /r is the return, form feed is /f, tab is /.
It's like HTML type.
Which one?
HTML, sir.
HTML, that one is different language, right? So those are tag based language, right? So
yes, sir, there is also bracket like this, so I thought like
no, this one bracket I have given. This one, forget about this bracket, just normally the characters we are printing, those are special characters, you can say. Those are like backspace characters. So you have the keyboard, you have backspace, right? So how can you print the backspace? How can you do the backspace? So that's why I'm telling that in the program you can do backspace by /b. So /n is the new line. So only the /n. Those are basically just showing you that those are the new line has been inside this to show you these characters, right? So this one are not, it's just a given. Okay, so don't think that those are the tag has been given. No, not HTML, not like that.
okay,
Just the character sequence. Okay, so /r is the return form feed. That's been, if you want to go, you are writing in here and then you want to go to the next form. So you will give some page breaks. You want to leave this space and then go to the next. Then you will use form feed. Okay, /f. Then we have tab /t, backslash, so double slash. Okay, then a single quotations, slash quotations, double quotations, slash double quotations. If you want to print double quotations, so that times you need slash and then double quotations, then you can print double quotation. Do you understand? Null is /o. So basically, the two important thing is that I want to distinguish this one, that when we write system.out.println, that doesn't mean that we are writing only system.out.println, which is reflecting to printing not a new line only. So it is not printing only new line. new line and the return, right? That's mean that carriers return. So this one is called carriers return. Carriers return means, like previously we have typewriter, right? So typewriter, and in the typewriters, the character will be typed, the carriers return. So this one is the carriers. So a tape, like tape we have, which is basically ink, will fly from here. So when you type, so that's mean this type has an iron body, so this body will come in here and place like a type, okay, the character, and this character will print on top of the paper. Do you understand? Like this way it will hit hammer, as like hammer it will hit the, so when you p, so p as a hammer, so hammer has a p written, so that p has been, and that p has been, I mean, forcefully write, forcefully push into the carriers, and that carriers has a blank tape, which is ink is in there, so it will be right in the white paper. Do you understand? So in that way, whatever you will type, so those hammer will go and place, and then it will type. Okay, after typing, when you finish the one line, so that times you need carriers return. So that's mean it should be come up to the first one again, and that way basically it will do again. So the carriers, this one is return, is this one is slash r, so you have to come back to the font and slash new n, that's been the next line. So you can do these things in two ways, so slash r slash n, so that's mean printf new line, or slash n plus slash r, because slash n means whatever you are, go to the new line, and slash r means come to the beginning. This is the same part as wherever you are, come to the beginning and new line. So there's the same thing, right? So that's we do it basically. That's we do basically when we write system dot println. Okay. Now we have several data types we have. Okay. So during other languages also the similar kind of data type we have, but in Java we have, actually we are differentiating two different data type. One is the primitive data type and another one is the non-primitive data type. That's we share from C or C++. The type we have data like integer. For numeric we are representing, we are integer we have, so all are smaller hand. So integer, floating point we have floating point, float we have double, we have character type char, we have character type, we have boolean boolean, so boolean type as well. In that way basically we can represent the types. So these types are inheriting from C++. So those are not basically objects, those are basically normal type data types, so those are called primitive data type. While we also have some other types, data types we have in Java for representing objects, basically, we have class, like class A. Why this one is a type? So because you have a class A, when you declare an object, so you define like A1 equal to new A. So that's basically new A. So this one is a reference variable of A. So class reference variable. Okay. So this class reference variable, this type of class can be referenced by this variable. So that's why a class A type reference variable we have taken. So this one is basically the class variable we are talking about, this one. Interface, as like class we have interface as well, so interface types of reference variable we can declare as well. So those are basically called interface type. We have array, so array can be represented as an object. So array is basically a sequence of numbers or a sequence of characters we can put together. So but now array in Java we can represent them as an object as well. So as an objects we can use this array. So we'll see the utilization of array maybe next class. Okay, so next week we'll start object-oriented programming. Must. Okay, when you go for data types, okay, so we have data types like byte, short, integer, long. So here if you go through this one, then byte is basically 1 byte size, that's been 8-bit, and the range of the values we can put plus 127 to minus 128. Short type is 2 byte, which has 32,767 to minus 32,768 basically. Okay, integer is 4 byte, which is plus 2 log something, this one to, it should be to 8, and elongated this one to this one. So we have several numeric data type we can declare. So why do you need data type basically? Okay, so data type is required because when you are defining a variable, that's when you are giving a name. So that variable doesn't mean that variable mean and space in the space, that variable should have to allocate an space in the memory. How much size he will allocate, that's a very important point. How much size he can allocate, this will be depend on the type, what type of variable this is. If this one is integer, that means he will allocate for a, the value he can be allocated from this plus at the value to at the value minus at the value, right? So within this any value he can store. So how many byte it may require? So 4 byte of data space is required to represent one integer variable. In that way we have long short byte variables, those have different sizes, and those we can allocate the memory spaces as well. Okay, fine. Now the question is coming that, sir, why you have shown all are signed numbers? Is there any unsigned type of unsigned type in Java? We are telling that no, there is no unsigned type variable in Java, only signed number. So okay, there is no unsigned number in Java, numerical value or floating point. We don't have any unsigned value, positive or negative, both we have. Okay, now if I will ask you a very important questions from that regards, okay, if I will ask you that, if you go through this one, this is the short type data type, we have y. So a variable we have declared which is short data type, that's been 2 byte he can allocate, and his data range is plus 32,768 to minus 32,768. So this value can be held within this range of value, can be any value within this range of value can be held by y. Now if you have 32,767, this value, so this value is 32,767. If you have this value, then if we do this operation y plus 1, what will be the y value? Y will be y plus 1. What will be the y value? Many people has done architecture with me, so they can mention, because in Java we have all 2's complement number. So what will be the y value? This is the highest value we have. Okay, so in sort type we have the highest value is 32,767. So if we do plus 1, what is the value will become? Many students done with me, right? Computer architecture. You forgot already? Can any answer? I can get any answer? Ibrahim?
So it will
What?
be 0.
It will be 0. So Ibrahim, Oshim is mentioning this one is 0. So any other y value will be 0 according to Oshim. Any other? Any other value? Minus 32,767. 767 or 8? So actually it should be 8. So this one should be the value. Why? Minus 32,768. Yes. Yes. So not the rates. The point is that if you go through this one, you check 0, 1, 2. We have 4-bit number, not 4 byte. 4-bit number has been taken. So when you taken the 4-bit number, the highest value is 7 and the lowest value is minus 8. So here you can see we can start from 0, 0, 1, 2, 3, 4, 5, 6, 7. The positive highest value we reach. Then if we plus 1, then it will come 0, 1, 1, 1, 0, 1, 1, 1 plus 1, which is basically 1, 0, 0, 0. 1, 0, 0 is minus 8. 1, 0, 0 is in the 2's complement. We have minus 8. then plus 1 will be minus 7, then plus 1 will be minus 6, then plus 1, minus 2, then this one is the minus 1, 1, 1, 1, 1 is the minus 1. Then again, after minus 1, we have 0. So basically, we have a circle. The number is rounding, basically, is the circle. 0, 1, 2. If you add 1, so it will go to like this, and 32,767. And then the next one will be minus 32,768. And then we have minus 32,767. And then we have minus 1, and then we have 0. In that way, it will continue as a circle. Do you understand? So this circle is basically is representing by the number systems of 2's complement number system. The circle is represented by 2's complement number system. So that's why when you use for loop or while loop, like while I plus plus, I will start from 0. Let's say I plus plus. So I will start from 0. So if this loop will continue, so I plus plus. So this loop will go infinite times because you are starting from 0, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if I is integer, so you will go to plus 21 lakh something, right? And then you will go to the lowest value. This one is 8, should be 8. Okay, the lowest value, and then plus. Then you have minus 1 again. You will come to minus 1 again, and then plus again. You will get start from 0. So it will infinite times. It will proceed. You understand? So this loop will not be stopped anymore. Okay, this will continue. Okay. Now we are coming to the floating point values. Okay, the range of the floating point is 32 bits size. In Java, they are taking 32-bit size. So floating point has the range is 1.4 e to the power minus 0.452 to 3.4 e to the power 38. Now, the question is that this one and this one, what does it mean? What is the meaning of E? What does it mean? So the meaning is that the value of 1.4 e to the power minus 48 represents as 1.4 e to the power. So that's mean that we have multiplied with e means 10. So 10 to the power here because we are providing in decimal, 10 to the power minus 45. So 10 to the power 40 minus 45. So this is the lowest value we have. So which means what? 1.4 into, so divided by, basically divided by 1 by 10 to the power 1045. So divided by 10 to the power 45. What is the meaning that? So 10 to the power, if you have 14, so if you have 14, then we have 10 to the power 44. Yeah, 10 to the power 44, because you have 46 basically. You have 14, so that time, sorry, you have 1 4, that times we have 44 because you divided by 10 already, right? So 1 4, and then we have 10 to the power 44. Now this one means that what? So you have, this means that we have point, and after point we have 14, and then we have 10 to the power 44. That's mean 44 digit we will have. So that's mean that 0.000000440 till 440, and then 14 we have. So this is basically the lowest number we can put in the floating point number. So 0.000. So here we have 440, and then we have 14. So this is the floating point number we have. So this is the lowest, actually lowest you can say like this. So we have also the bigger one. So it's positive or not. Let's see the positive number, the smallest one. So positive and not, that will be defined by the sign bit. So sign bit. So this number we can store inside. That can be positive or that can be negative. We can store inside the floating point number. So, and this one is the highest numbers, highest representations they are telling. So the range representation. So 3.4 into 10 to the power 38. So that's mean what? 34 into 10 to the power 37, right? 10 to the power 37, because from here I have taken 1. So I multiply this one. So that's why 34.0 basically. So now we have 34. So if we multiply this one with, so 0, 0, 0, so 37, 0. So 37, 0, then 38, 39. So we have 39 digit we have. So 37, 0 basically we have. And then we have 0.0. So this one, the highest number that we can put, highest positive number that we can put inside the 32 bit. And the negative of this one is the lowest negative number that we can put in the floating point number. Do you understand? So these are the numbers in the fractional positions, precision positions we can hold in the floating point number. The same way as the double will also represent. Now the question is that, sir, we have the floating point number, we have x, we have 10 to the power something when you represent the number, 10 to the power some things, and then we have floating point. After floating point, we have some digit as well. So how do you represent this one? So we are telling that when we store in the memory, so that times basically we use IEEE standard 754 mechanisms. In the 744 rules, standard rules we have, in these rules, like single precision, that's been floating point numbers, floating point, if you want to represent this one. So first bit, you need 32 bit. First bit is for the number is signed or unsigned number. So first bit is for if unsigned then 1, if signed then 0. Then we have, so 1 bit, and then we have 8 bit. 8 bit we have for exponent. 8 bit we have for exponents. So to store the exponent data, we have 8 bits. And then 23 bit exponent we have. 23 bit exponent we have, 23 bit significant we have. Significant, after floating point we can put 23 bit data. But obviously those are binary data, not like decimal data. Do you understand? Yes. Yes. Oh, we are multiplying. We are multiplying by, no, not divided, multiply. Yeah, so we have one. Oh, if you multiply by 10, so what will happen? 34.0, right? So 3.4 multiply by 10. And then so 37 we have taken. So now 37, 10 to the power 37, because 110 we have, I have multiplied. So take all the things in the upper point. Now if you multiply 10 again, so it will be 340. Then a 10 again. In that way 37. So do you understand? So 0.0. So this is the number. So here basically we have 37.0. Okay. For double, you have this amount of numbers. So these numbers we can represent by 1 bit as a significant sign bit, and the 11 bit for exponent, and 52 bit for significant data. So after floating point, we can store 52 bit data. Okay. So that's basically we have double precision values. So that's the way basically floating point has been represented. Not directly, the number is not representing in the memory. Basically the floating point exponents, and also the floating point is signed or unsigned, and the rest of the significant. That's mean the floating point, after floating point, what are the values? Those significant digits are 52 bits. So 52 binary digit we can store for significance. Now, by default, in Java, floating point numbers are double precision numbers. By default, when you declare a value, let's say 1.6, if you multiply something with 1.6, let's see, we have f. F is a floating point number. So f into 1.6, so that times the result will be come to double. Why? Because 1.6 is double here. So by default, if you are not placing anything after the floating point, by default this one is a double type. So you need to place an f, or like this f, or 1.6 f, like that. You have to place to represent this one as a float. So if this one is an f you are writing, so that times it will not be double, it will be float. Do you understand? It will be float type value. So it will be 32 bit precisions he will hold. But if you are not putting anything, so that times it will hold 64-bit precision. So that's why this one and this one has difference. Do you understand? 64-bit precisions he will take. So the second one he will take double precision, and first one will take the first precision. So that's mean that single precision 32-bit. Why you are wasting data if you have 1.6? Why you are wasting memory, right? Do you understand? So to make it float, you have to be put F or capital F. Any question? Yes. But if you want, yeah, if you want float, so that times if you think that this value will be float, so that times you will put F. Okay? If you don't think that this one is not float, so don't need to put F. Now in Java also we have character type, which is a little bit different from C, C++. When in Java, C, C++, we have for character type, like character A, character CH, when you declare, so that times CH will take only 1 byte. But here, when you declare in Java's character CH, so character will take 16 bits. Now the question is why? In C, C++, C and C++, it will take 8 bits, 1 bytes, but here they will take 2 bytes, 16 bits. Why? That's the questions can come, because in Java we can represent the ASCII values. So ASCII values 1 byte is enough to represent 1 byte. So American standard, the English values, okay, English characters, what we have the keyboards. So those values, then we have only 8 bits is enough. So that's basically called ASCII values. But if you want to store the world other language values like Bangla, like Japanese, like Chinese, so that times you need Unicode. Okay, so you need to represent as Unicode. So that times you need, so Unicode, each character in the Unicode is 16 bits, 4 nibble hexadecimal digit, 4 hexadecimal digits. So 4 hexadecimal digit combined 16 bits. You understand? 4 into 4 is 16 bits. So Unicode, for representing Unicode, that's why Java used the character CH when you declare CH for 16 bits. So Unicode basically a computer encoding methodology that assigns unique number for every character. It doesn't matter what language or computer platform it's on. So he doesn't know about this one, but it doesn't matter what language and outputs a computer platform it's on. So he's using like Unicode. All the languages in this world, all the characters in this world can be represented by 16 bits. So Java you can represent in Java. So so now how can we distinguish that this is ASCII value or this is Unicode value? When you are assigning value like character 7 equal to 7, so this time you have defined as a character, so that's why this one is 7, right? So this one will take ASCII value, normal ASCII value. If you place the decimal value of the ASCII value also, then it will take 77. You can also place like CH equal to 0x7397C, 0x not 73. It can be 7. It can be 79. 79 is basically hexadecimal. 79 is basically Y, so it will be represented as Y value. So in this way or in this way, decimal value or in this way. So this one is the ASCII value of the decimal value. 77. 77 means like M. So this one is representing M. So this one is representing Y value. You can also put hexadecimal value. Hexadecimal 2 digits is enough for 16 bits, because one hexadecimal digit will take 4 bits. So 4 bit and 4 bit is 16 bits. So the character letters, so when you use letter equal to, so how can we define Unicode? If you define one to Unicode, so /U, then you have to give 4 hexadecimal digits. Let's say I want to represent C. So what is the 4 digits? So this one is 00004, and then 0, this one 1 2 3. So this one is 3, right? So this one is 3. So that's why I'm taking 00043. So this one will represent C. So this character is basically Unicode character C. In that way we can represent. Like here we have represent 0037, which means that 3 is 7. So 0030, 31, 32, 34, 35, 36, 37. 3637. Basically 7 is the 37 because we have 7 here. So we have 7 here, right? So this one is the 7. Yeah, this one is the 7 number. So that's why 3 and then left of this in the column. So that's why we have 7. So 3 7. So 3 7 we have is the letters, which is basically 7 letter. Okay, that's basically 7. Okay, so those are basically Unicode, and the difference of Unicode and ASCII code you can define, right? You can put. Now let's go to the examples that we're going to show how you can print the Unicode as well, like this one, system.out.println /new2300. So 2300 is a Unicode number. So this one is a Unicode 5 Unicode, this one. So that will be printed. But here you see /u1003. So this one is basically Unicode 1003. After that, all the things he will take as a character. So ASCII code. So like, so 1003 is basically omega, and then this one he will take as a character, so which is 5. So 5 he will represent now. So this one is the output for this one. Now for this one, you can see the same way, not only one, but if you have more characters, so the rest of them will be after Unicode, because you have /u, so Unicode is in there. 4 bit you will take, four characters you will take, 4 hexadecimal digit you will take, and rest of the 1 to 3 will be printed as a digit, as a literal. They will print, okay, as a character. Okay. Now, if you want to print two Unicode together, so /u00003 or /u0037 /u0030037, and then again /u00A5. So /u, you have to make /u, and then the Unicode number of the digit, then you can find out this digit. In that way, any Bangla character, every Bangla character has a Unicode number. Do you understand? Every Bangla character has Unicode number. Okay. I'm not sure C and C++ is supporting Unicode or not. Java support Unicode. That's why we are using Unicode in Java. But C and C++ is not, I don't think they have the Unicode. They just use ASCII. Okay. So now we have the Boolean type. But obviously, Bijoy has been written in C++, and they use Unicode for that one. Okay, so you can search for that one. That because Bijoy is Bijoy has the Unicode facilities, right? So Bijoy's all characters are Unicode. So, but so far I know Opera has been written with C++, because Dr. Munir has taken Dr. Munir. He built up this one. So that time he mentioned, we know that time we were the final year students. We know that what happened behind this Avro keyword. So I think that Ekushe Podok should have to give in Avro. I think so. These are the first characters, that's Bangla characters they have presented, right? So it should be given. But anyway, now I don't want teacher and students should have the conflictions. Don't want to know those things. Okay, teacher is teacher, so that's another issue. Okay, so don't want to conflict anything, but I want the Ekushe product should have to go to Avro. Okay, that's my wish. This is from my aspect, because I know they inherit everything about Bijoy and Munir Hassan, and also what happened with the minister we have, right? So anyway, Abdul Jabbar. Okay. So anyway, that's a different issue. But so that's why you can search. That's why I'm telling that, because C++ is the backend module that's developed for Avro. So you can search. Maybe there is a way to use a Unicode for C++. There are some modules, maybe. You have to header file. You have to include. Maybe, I'm not sure. You can search. Okay. So Boolean types, we have Boolean types. Okay, Boolean types. So Boolean, in Java, we have Booleans as well as C and C++ as well. So, but remember that when you declare a variable Boolean, so that times by default, the value will be false. So before using that one, you have to assign the values if it is true. So the value can be two types. One is the true and false. The literal are two literal. One is true and false. So before using the Boolean value, you have to be initialize this one, because without initialization, by default, the Boolean value will be false. Very careful about the Boolean, okay? Now, providing the variable value is very important, right? So how to assign the values to the variable, how to give the value to the variable. So one of the things that we do by using the statements, like by using the equal expressions. So through that we can assign this value to there. Okay, so this is like it's an expressions we are doing, right? An expressions, and then now we have the statements. So this one is an expression statements. So this value will assign to here, right? So assign. So by assigning this value, we can use the equal sign and put the literal value to there, like integer, and we can initialize those values like integer value 100. So variable has been get this value, character yes x, double total 75.37. In that way, you can represent this value, right? But if you need to read from the console so that dynamically you can provide the value to the variable, how can you do that? During the running time, you want to give the value, not the compilation time. During the running time, you want to assign the value to the variable. How can you assign this one? There is a class called a scanner class. We already use this class, and this class has a method which name is next double method. So by using this one, so input.next double, which is an object reference of a scanner class. So by using this one, we can take the input, and that input can be placed to the variable as well. So in that way, we can take the input from the console, and that can be placed to the variable as well. Remember this one, this sentence, a scanner tokenized input. So he separate the input according to a delimiter, white space, tab, and new line. So white space, tab, and new line, he separate those for input. Do you understand? So remember these things, okay? These things is very important. Now, there is also another way. Basically, in the scanner class, we have some basics. Scanner is a new class that is built inside the utility package. Okay, so scanner class also use data input streams. Like scanner class is used to collect the data only from console. A scanner class you cannot use for reading the data from the file or reading the data from the network sockets. Okay, the stream data you can't, like 1010 it's coming, stream of data is placing, so that times you need to read, so that times you cannot read with a scanner, because the scanner is built by using the data input streams. Okay, data input stream class. So it's better to know this input class. Okay, so because this one is generic, you can take the data from any place, just you need to mention that what is the format of your input, where from you will collect the input. You have to change the system.in when you want to take from file. We'll do that. But so far, you can learn that data input streams, how the data input streams is used. This is similar as like scanner class. So scanner class you have from util, but here util package, but here we have IO package for data input stream. We also have data output stream as well. So here data input streams in the same way as like scanner in equal new scanner system.in, we are calling data input streams in equal new data input stream system.in. And data input streams has a generic function which is called readline. Generic function which is called readline. The in.readline. Rather than you don't need to consider like what type of values we are reading. So he will take in.readline, and this one will be converted. This one will be taken the input as a string objects. So in.readline will return. I will teach you about the integer. Okay, so I would like to let you know from here. Okay, we have integer, the primitive type, as well as we have the class type as well, integer, because we want to make Java in future has the possibility that Java can be a full field of object-oriented language. That time you don't need to study integer, float, something like that. Okay, so like float data type, primitive data type has a corresponding float classes. Okay, so this class has some function who will manipulate the float values. So that's why we have corresponding classes as well. So this one and this one. Okay, so these are called wrapper class. When you go for a string, so that times I may talk wrapper class, or array, we'll talk after the array, we'll talk wrapper class maybe, or after the object, we'll start to talk wrapper class. So, so conversion between them is required. So some functions are there to convert them. Okay. So remember those. So that we'll learn in future more. Okay. But just for the time being, I'm just wanting to tell you that we have integer, float. Those are primitive type. We can convert this one to non-primitive. We have some similar kind of classes. We have now objects of classes, or objects, you can say classes. We can create the objects of the class type. We have wrapper class. Those are called wrapper class. So we can utilize wrapper class when we have full object-oriented aspects you are thinking. Okay, so we are taking, so this one is, and we have taken an integer value, integer number. Okay, so read line is a generic method which can take, like for scanners you have for integers, next integer. For double you have next double. But here you have a generic class, generic method which is called read line, which will take string objects. So we also have an object of a string. We also have an object of a string. Capital letter string S is basically an object of a string. So these objects, strings, I mean class of strings. Okay, so they will take, so you will take an object which is basically string type objects. Okay, string type objects. So one value will come which is basically 1 2, let's see, you have given 1 2 3 1 2 3 4. So you will take as a string of this one. Now to convert this string to integer, this integer, object integer, so object string to object integers, you have a function which is called integer dot parse integer. So it will convert this string to integer class. So integer, integer type. Do you understand? So string object to integers, you have mentioned this one, right? And now these integers, now you are telling that, sorry, you have primitive type. So this integer will autocast to automatically will place two integers. So if you place equal sign, then it's enough. So he will place in integer value, automatically he will convert this object to integer automatically. Or you can call integer dot int value. Here is float value, integer value. Then it will convert this value to integer value. Do you understand? So that function you can call, or you can directly put this one. Auto boxing will do. Here auto boxing will do. Object to primitive type will do auto boxing. Okay. So now, so this one you have read as a string and then integer dot parse integers. Okay. You can also do another way to parsings, like you can read and then we have. So now you are reading the integer string. So this one is a string objects. So object is string, and then float dot value of. So this one will get this one converted to float object, and then dot float value. So it will convert to again float type, primitive type. Okay, so that's why basically we'll do this function. We'll do and we'll exercise on this function. Okay, so now we have the float value, and float value will be placed into float number. So two-way auto boxing and boxing has been shown in here. Okay, so that has been shown in here. I will show more details about auto boxing and other boxing issues. Okay, so that's I will show in here. Okay. So that way, basically, you can take the inputs. You can also take the inputs and you can assign to the values as well. But conversions is very important because you need to talk about, like, scanner class will not always use just only from console. You can use a scanner class. However, file, socket, you have to learn how to convert those things. Okay, so those are basically handling the wrapper class. That's very important. So we'll learn these things. Just to remind me that, sorry, you told me that we gotta learn wrapper class. After array, we'll learn wrapper class. So the default value for various type of elements. So like various type of variables, we have like byte, we have default, any value variable will take 0. Short will take 0. Integer will take 0. Long will take 0. Float will take 0.0. Double will take 0.0. Characters will take /u 0000. Remember this one, Unicode 0000, which is basically Unicode 0000, which is basically I think null. No, null, yes. So null is the Unicode for 0000. You understand? So that is the by default value for character, by default value. String null, and Boolean will take false. Okay, Boolean variable will take false value for input. Now, very important topics we have, which is basically uh, chatta pochish. Okay, so we have 8 minutes. So let's finish this one. We have very important topics, which is called typecasting. Okay, so I just want to clear you that typecasting, we are happening this one, typecasting between primitive type to primitive type. Don't think about object type. Primitive type to reference type is not possible. It's not possible. Okay, primitive type to typecasting to reference type. Like mean any class variables, you cannot convert this one to integer variable, right? So primitive typecastings is very you cannot convert this one to reference variable. So one student asked me in last class that, sir, can we what is the typecasting of array if we a string to convert this one to integer? I said that no. I said that okay. So if you individually do this one, so that times that can be character to integer. So that times it will be um, character to integer. So that times will be widening castings. Okay, but full objects we cannot do that one. So that's it's not casting. That is another issue. Another conversions that we take reference to reference. We can talk about in that way. Okay, so reference conversion or casting. That's I call you auto boxing or other mechanisms. That's we can do, but not like array conversion. Array is not a primitive type. Array is not a type. Array is an object. Okay, so array type, you don't have any primitive type to array, so there is no conversion between happen in these two figures, right? So primitive type to primitive type, objects to objects. Don't think about object to primitive type to object. That's different issue. That's not casting. That's a different issue. We are calling this on boxing. Okay, so auto boxing or other things. That's I will talk later. Okay, so typecastings. Oh, always I'm telling later things. Okay, so let me check this one, that auto boxing, and what is the name of this one? There are some general names out there. I forgot the name. Okay, let me talk about these topics later. Okay, so when we have these topics, then I will talk. I have these topics. I have the slide as well. So that times I will talk. I plan to talk on that period, like array and strings. So that times, just would like to show you that yes, that's the topics I will teach. Don't worry. Yeah, autoboxing and unboxing. Sorry, unboxing and autoboxing. Autoboxing and unboxing. So we'll talk about this one. Wrapper class. We'll talk about this one. Okay. See value, integer value, converting integers. Okay. And float value, and value of functions. Where is value of? Yeah. So dot value, float value. So this one we did, right? So float value. We did here float value. Yeah. Yeah, float value of. Float value. You see, float value is the conversions we do. Yeah, that's we're gonna talk about those things in the wrapper class when we study wrapper class. After array, I will focus on the wrapper class, and I will finish this one within one class. So you don't need to worry about those things. We'll learn. Okay. So now the point is that when we are talking about typecasting, this typecasting, we are talking about primitive typecasting. Okay. So primitive typecastings, we have two types of primitive typecastings. One is called widening casting or promoting casting. Why widening casting? Because why promoting casting? The name itself representing the meaning. Okay, don't forget, from the name you have to find out the meaning. So widening, that's mean বড় করা হচ্ছে। তার মানে ছোট থেকে বড়তে যাওয়া হচ্ছে। ছোট type থেকে বড় type, smaller type to bigger type, smaller size to bigger size. So type means size, okay? Smaller size to bigger size. Widening, implicit. That's mean internally, you don't need to do anything. Internally, it will happen. Compiler will do everything. You don't need to worry about these things. Automatic compiler will automatically cast. You don't need to make anything into write for the castings. Like from byte to short, byte to integer, byte to long, or short to long, integer to float, integer to double. If you cast like that, so from these values you need to go from there to the higher size. So that times you need, like, we have the smaller size to the bigger area if you want to place. So that times this value will not be lost. So as the value will not be lost, we have no problem. So the value is like float, we have larger area, so we can float A. So if you have an integer B, if you have so integer B, so that times A equal to B, we can write. Okay, so because automatically they will cast this one. So this value can be stored in A, but A has larger space than B. So it can place in here. If you have double in here, so it has larger space. So integer value can easily put in this variable. So those are called widening casting or promotional castings. Okay, implicit, because this casting doesn't need to any command. You don't need to give any command from outside. You don't need to do anything. Compiler will do that casting automatically. You will convert this one to this one automatically. You don't need to worry about these things. So that's basically called. And we will not lose any data. Okay, all the data we can keep, because from a smaller space we are going to bigger space. So all the data we have to keep, we can keep. Now the opposite one is the narrow castings or explicit castings, where we have the larger one to the smaller one. We are proceeding from the larger one to the smaller one. Okay, so now we have to think about this one. So we have lost of data. Maybe we will lost the data. So because it has bigger space, so bigger space, bigger data, we are putting this one to a smaller area. So maybe we can lost data. So that times compiler will ask you, are you giving the command? Is it right to convert this one? Like we have float A and we have the value float. And if you want to convert to B, so integer B, we have integer B. So we want to place A, so we cannot directly write A. We'll write this A, so compiler will say, no, there is an error. I cannot. This one is different type to this one. This one has bigger size than this one. If I will convert this one, maybe I will lose data. So that time you have to mention explicit. You have to mention this one by force. Do that. I'm commanding you to do that. How? Integer. You are telling this one integer. Cast this one to integer. So this value will be cast to integers, convert to integers, and then integer will place to be. So you are telling that casting that one. So that casting is called explicit casting. From outside, you are casting this one. You understand? So that's why it's very important, the casting. You have to remember this one. So you need to write. Okay. When you go for double to float, we have, you see, we have 53 significant value for double. We have 53 significant value for 53 significant value, right? After floating point, we have 53 significant value. And for floating point, we have only 23 significant value. So how can we convert this one to this one? So if we place this one, then obviously we have a limited number, 23 digit we have to convert. So 53 to 23, we have to cut down this one. How can we cut down? This method is called round up, rounding or round. Rounding, I'm telling. There are different methods we have for rounding. But let's see, rounding we need to do, because after 23 bit, if you have 5, let's see, we are doing it this way. After 23 bits, if you have 5, so the spin you will add 1. After 23 bit, if you have 5 and greater than 5, so you will add 1 here. So 1 in the last bit. Okay, so if your last bit is 8, so and 1 9, then round this one. If you have less than, so truncate, cut off. So just remove those things. 8 is in here, no problem. Okay, so that way basically we can make shorter precisions than the broader precisions. Okay, now when you have in long to integers, if you have a long value, okay, the same value if you want to keep. So what the compiler will thought that, okay, the long value, that's been bigger value you have. Long, it's 8-byte value. So we have 8-byte is 0. Let's see, 8-byte is 0, and then he thought that the last 8-byte is the same. You want the last 8-byte because we have the integer. Sorry, for long we have how many bytes? Long is how many bytes? Long is 8-byte and integer is 4-byte. So you want to convert this one from 8 byte to the 4 byte, 8 byte to the 4 byte. So long, for compiler thought that, okay, you just keep the 8 byte. You don't want to keep the upper one, because upper one maximum time, upper ones will be 0. So that's why from the long space, because if you have some digit in here, so you don't want to convert, right? But if you have like 0, that times you want to convert, okay, this one can be replaced into shorter place. So long to integer you can take. So that times the upper ones will be 0. So that's why you can neglect the upper bits. So when we are converting from long to integers, so that time the upper bits will be discarded. You understand? The upper bit will be dropping the higher order bits. And from double to floating point, the precision, to maintain the precision, 23 bits, we have to round up this one. Okay, so that's obviously left significant bit is here, most significant bit is here. So most higher order means most significant bit will be removed. You understand? Because let's see a number you want to represent, right? In binary, think about binary. So 1 1 1 1 1 1 1 and 0, right? So let's see, we have this 8 bit, 4 bytes, right? So 4 bytes we have. 4 bytes mean 32 bits we have. So 32 bits like that, and rest of them are 0. So this one is also 4 byte, so 32 bits. So 64 bit we have 0 0 0 0 32 bits, and rest of them is. So now if you want to take this one to integer value, so this value will come. This value will come to integer. Those value, the higher order bits will be removed. We don't need. You understand? So that's we are thinking. So maybe sometimes you need to lose the values as well. Okay, sometimes if you have 1 here, you're losing the values. But the compiler will think that why you are casting, because it has a smaller value in here. You don't need bigger space. So that's why the higher values are not required. So that's why you are not considering the higher order values. Okay, just thinking about the lower values and then putting in there. Do you understand? Any question? Do you have any question? Okay.
No, sir.
So that's it for today's class, and the next class we'll complete this one, and then we'll start the object variables. Okay, the class and objects, and that's it for today's class. Thank you very much. Take care of yourself. Okay. So.
Okay, sir. Assalamu alaikum.
Thank you, sir.
Bye.
Assalamu alaikum.
Huh?